Okay, so today we are going to touch on the resource book, page 21, on the topic of angle of elevation and depression. So the fundamental question now, the very basic question is, which angle is known as the angle of elevation? Which angle is known as the angle of depression? So now, let's say I'm standing down here. This is my eyes level. Okay, and I'm going to look up at the aeroplane. So there is a line of sight here. So now it must be on the horizontal ground, and then I'm looking up, Farhana. Okay, this angle here that I measure is known as your angle of elevation. So let's call this my eyes E, and this call it to be P, the plane. So this angle is now known as angle of elevation of the plane, so of P from E. So it's a bit like bearings. So from E, I will look at the plane. Now, I have money down there, $2. So at the eye level, I need to look down at the money. So the money, let's call this M here. And this angle now is known as, from the horizontal eye level, I look down. So this will be called your angle of depression of the money from my eye level as well. All right? So that is the concept of angle of elevation and depression. The angle of elevations of my eyes, all right, to the aeroplane, that means the angle of elevations of P from E, it will be this angle here. Imagine that I am now in the aeroplane and I'm going to look down. So I'm going to look down at E. So what is this angle here? This angle is called the angle of depression. Okay, help me out here. Of which letter? Which letter? I am looking at the angle of depression. I'm looking at this now. So E from P. So I'm looking from P, the aeroplane, and I look down. Just now I was standing at the ground here and I look at the aeroplane. Now there's something very special about these two angles. What do you know about these two angles? They are alternate angles. Very good. So because they are alternate angles, so these two angles are the same. They are equal. So I write one more time. Angle of elevation. This is a very important concept. Of P from E is the same as finding the angle of depression of E from P. Now the letters swap. So most of the time we do not want to find angle of depression because it's somewhere above. So what we do is we will look for the angle of elevation because it will be the same as finding the angle of depression using alternate angles. Now let's look at what type of maths question is going to come out. So this is example 2 from your resource booklets. They say that this is a tower, a building. What is this angle here? Common sense? 90. Okay, because it's a building, right? You must build the building vertically up, so it will be 90 degrees. And I'm asked to find PQ. So this is the length that I'm asking to find. But they tell us one more extra info. The angle of depression, they told us this, they told us in the question, if they never draw the angle for you, you must draw yourself. Angle of depression of P from T. Of P from T. So you realize that this angle is the same as which angle here? Below, right? Here? Here? Yes, okay. So now I will simply just use Picasso. And that's it for this chapter. Very simple only. Okay, now I want to find X, right? You see that there is a right angle triangle. So we will use Picasso. Okay, we are not using Pythagoras because there's an angle here that we need to use. So what we will do is we will label this as opposite. This one is adjacent and this is hypo. but we are not using this, so I will not label. This is not our first lesson, so we will just label these two. Now, under tuakaso, which one are we going to use? I have opposite and I have adjacent, so definitely I'll be using tua. So first step is to always write down the formula. Otherwise, we tend to make mistake. Now, do we have the angle theta? Okay, so answer is 40 degrees. And do we have the opposite? And we have the adjacent as x. Okay, question your WA1 is coming around the corner. How do I find x? You swap. Yes, very good, Irfan. We swap. Okay, so this one will go up. But after that, this one will go down. So we do a swap. So the tangent 40 and the x will replace each other. Okay, so now, thank you. I need to check whether this answer is reasonable or not. Is it okay to have 95.3? Looks okay, right? Because this is already 80, so this is okay to be 95.3. Yeah, that's the length. Oh, sorry. Okay, that's the length. I think it's meters, it's fine. Now, for this question, all right, it may look a bit complicated, but it's the same as the previous one, just that now you have two right angles triangle. That's all. It's the same. You have done this before, so let's look at it. Now, TF is once again a building, so the angle F is automatically, you draw it as 90. Now, we are not assuming, we know it's 90 because it's a vertical building. The question says that you realize they never draw the angle for you anymore. The angle of depressions of A from T. Okay, let's focus on the first line. I go from T and I look at A. So the angle is this. What is this angle? 29 or 51? From T, I look at A. From T, I look at A. So this angle is 29. So this 29 will be same as this angle here using alternate angles. Okay? Well, next, they tell us another info. The angle of depressions of B from T. From T, we look at B. Okay, now the angle is quite big. From T, I look all the way to B. So this is the angle. And what angle is that? That will be 51. But this angle is very ugly, right? On top, quite messy. So do you know that this angle is the same as which one at the bottom? Do an alternate. Alright, that's why I purposely use different colors. So what the question is actually asking is, now we just do as per normal tuakaso question, but the only extra step is the angle of depression of A from T is here. So this angle, I know it's the same as this angle, okay, as covered earlier. This purple angle is the same as this purple angle, as covered earlier for alternate angles. How do I find AT? I know that part of it here is 36. Here is 29. Here is 51. So now I can find the other angles here. So 180 minus 51, what angles are we getting? So this angle here is 129. Okay? And in order to find AT, we have an opposite pair, but we also need an opposite pair here. We are going to use sine rule. So help me out here. What is this angle? If this is 29, this is 129. What is this angle here? 180 minus this should be 22, right? Okay? So we have 22. Now there's many ways to find that this is 22. This is just one of the ways. I will use sine rule now. So just note that even though this is a right angle triangle, I need to use sine rule. So how to find AT? I have AT is down here. So AT, this one you can follow. I give all the values already. So can you help me out here? AT over sine what angle? Which angle am I using? AT over sine. Choose which angle? The opposite angle, 129, equals to 36. I must use this length over sine the opposite angle 22. So finding AT is simply 36 over sine 22 times sine 129. 74.7. Let's keep it short lah. Okay, let's keep it short. So 74.7 meters. Now we know that this is 74.7 meters. I'm asked to find this height here. Whenever you have problem seeing such a complex picture, please redraw it. And what angle is this? Look at the picture. I'm going to redraw. Is this 29 or 51? Okay, my aim is to find the height TF. What angle am I having here? The angle should be 29. Okay, so this is F, right, I think. Yeah, F. Okay, again, Tuakaso. So I told you already, the last part is actually easier. So let's do Tuakaso. This is opposite. This is hypo. Should I use Tuaka or so? I should use sine theta equals to opposite over hypo. I have the angle 29. Opposite is what I want to find. And the hypo is 74. I keep it short. Actually, you shouldn't write this little number of significance. I keep it short so that it's not so daunting. So the final part will be cross multiply up. And the final answer, the height of the building is 36.2 meters. All right.